Hello everyone, welcome back to the AI Tools Research Channel. I'm Zeb Batty. Many among you have probably heard of the Metaverse, and surely you must have run into a wide range of definitions and explanations of this mysterious term. In this video, we'll attempt to demystify the Metaverse concept, if you will. We'll specifically explore how the rapid evolution of artificial intelligence, computer vision, and breakthrough immersive technologies is giving rise to a new digital frontier, the AI Metaverse. Neal Stephenson invented the metaverse, at least from an imagination standpoint. Though other science fiction writers had similar ideas, and the pioneers of virtual reality were already building artificial worlds, Stephenson's 1992 novel Snow Crash not only fleshed out the vision of escaping to a place where digital displaced the physical, it also gave it a name. Stephenson's ambient, persistent, and immersive alt reality, a virtual universe inhabited by avatars that engage with one another digitally, has become the next step in computing. Metaverse has become a buzzword and a near reality. Metaverse in its most simple form is a network of immersive digital spaces that integrate the physical and computer-generated virtual worlds created in these digital spaces. It presents unique and revolutionary ways to communicate, interact, and create new experiences. So in this respect, the Metaverse can be broadly defined as a network of immersive virtual worlds, created using a range of frontier technologies to mirror or transform real-world experiences. And the other important characteristics of the metaverse besides immersiveness are persistency, heterogeneity, and interoperability. Since the recent emergence of generative AI, content creation of all kinds, text, images, audio, video, 3D characters and replicas, animation, music, and many other forms of user-generated creative content synthesis has exploded. Gen AI is fueling the expeditious iterations and improvements of the metaverse, and Gen AI is poised to accelerate the development and use of innovative applications in these digital spaces that will have immense impact on our everyday life. Some simple examples are the creation of imaginative virtual worlds, avatars and digital twins, music and songs, and of course stories and other creative content generated by AI. Many industry leaders, technologists and policymakers have viewed the progression of the metaverse as an intriguing and significant milestone in the next generation of digital communications and interactions. Imagine conducting Zoom-type meetings and conferences at meeting venues generated on the fly, venues like islands, beaches, resorts, or whatever you can conjure up. Against this backdrop, it is useful to better understand the opportunities and challenges presented by the metaverse and its associated technologies, thus facilitating its robust potential integration into the industry, commerce, and our social life. Standards for the fundamental elements and technological underpinnings of the metaverse are also beginning to converge. The maturity of enabling technologies, including network infrastructure, computing infrastructure, sensing technologies, artificial intelligence technologies, and distributed ledger technologies that underpin the construction of the metaverse, is giving new hope for Stephenson's ambient, persistent, and immersive alt reality to be realized much sooner than previously anticipated. Credit for this renewed excitement and hope goes to the rapid growth of AI adoption, particularly generative AI. The development of the AI-powered metaverse is poised to bring new business opportunities to the industry by driving demand for virtual services and enhancing business operations. As a new paradigm interconnecting the physical and virtual realms, the metaverse potentially brings the prospect of particularly reshaping the services landscape with creative interaction models that facilitate seamless commercial and financial activities. Now let's delve a bit deeper into the main characteristics of the metaverse mentioned earlier: immersiveness, persistency, heterogeneity, and interoperability. First, we have immersiveness. Immersiveness in the metaverse refers to the user's level of engagement and absorption within the virtual world. Through the real-time transmission of multi-sensory information between physical and virtual realms, users can fully immerse themselves in the metaverse. They can perceive objects and surroundings in the virtual space through their senses, creating a heightened feeling of presence. Users' facial expressions and physical gestures can be mapped onto their corresponding virtual avatars, facilitating real-time communication and interaction with other users and the virtual environment. This dynamic interplay between the physical and virtual worlds increasingly mirrors real-world activities, enhancing the overall immersiveness of the metaverse experience. Next is persistency. The persistency of the metaverse refers to the concept that the virtual environment within the metaverse remains consistent and continuous over time. It implies that the virtual world persists even when individual users log off or leave the computer-simulated environment. This feature provides a sense of synchronization and progression within the metaverse. In a persistent metaverse, users' creations and contributions persist over time, allowing subsequent users to experience and interact with them. This feature enables the virtual environment to evolve and develop, reflecting the collective efforts and interactions of its users. The metaverse thus becomes a dynamic, ever-changing space that is shaped by its users. Then we have heterogeneity. Heterogeneity in the metaverse refers to the diversity and variety of virtual worlds, platform characteristics, and experiences that coexist within the metaverse ecosystem. It emphasizes the existence of multiple distinct virtual environments, each offering a unique set of characteristics and purposes. In a heterogeneous metaverse, users can select the virtual worlds that resonate most strongly with them and tailor their experiences to suit their preferences. Users can seamlessly navigate between different virtual environments, switching between diverse activities and social contexts as they see fit. These options allow users to create a personalized metaverse experience that caters for their individual needs and interests. And finally, interoperability. Interoperability in the metaverse refers to the ability of various virtual worlds or platforms to seamlessly connect and interact with each other. This ability allows users to move and transact across an interconnected network of virtual platforms while retaining their virtual identity's assets and data. For example, users can use the same avatar or items across different virtual platforms or transfer virtual currency from one platform to another. Interoperability is essential for creating a unified and interconnected metaverse in where users can access a variety of experiences across different platforms. It fosters the development of standards, protocols, and technologies that enable seamless communication and data exchange in the metaverse. We earlier mentioned the technologies that underpin the AI-powered metaverse, or the key components of the metaverse. As a network that intertwines the physical world with virtual realms, the metaverse thus has to provide users with a seamless experience of interaction and immersion. The metaverse heavily relies on a variety of enabling technologies to interconnect physical and virtual realms, where users can experience various activities in the virtual environment. We can call these focused technologies. Here is a list of these focused technologies: network infrastructure, computing infrastructure, sensing technologies, artificial intelligence technologies, and last but not least, blockchain and other forms of distributed ledger technologies. Let's briefly go over each one. 1. Network infrastructure. Network technologies such as 5G, 6G, the Internet of Things, IoT, and software-defined networking, or SDN, can enhance communication reliability and availability in metaverse-related activities. 5G networks can support a greater network capacity with lower network latency and higher data transmission rates. 6G networks are expected to further strengthen these capacities through ultra-high data transmission rates, ultra-low network latency, and improved network coverage. These improvements can potentially address the issue of growing network traffic within the metaverse and allow metaverse platforms to serve numerous users simultaneously. The interconnectivity of IoT devices facilitates the real-time collection and transmission of information, which can enable seamless interactions between users and the metaverse space, thus enhancing users' immersive experience. SDN technology can empower large-scale metaverse networks by using software applications to intelligently and centrally configure and control the network. This technology provides numerous advantages, including enhanced scalability, flexibility, and simplified network management, leading to efficient low-latency information transfer. 2. Computing infrastructure. Computing technologies are essential for processing vast amounts of data quickly and enable reliable real-time virtual interactions in conjunction with network technologies. Cloud computing is used in the metaverse to store, process, and access data through central cloud servers, supporting data computation and virtual simulation. However, as the number of metaverse users and latency bottlenecks increase, this centralized computation infrastructure may suffer from problems such as latency issues, low graphics quality, and limited scalability. Alternative solutions such as edge computing, fog computing, and in future, quantum computing may offer remedies to mitigate these drawbacks and thus complement the performance of cloud computing infrastructure. Edge computing allows real-time data processing and storage within local edge devices instead of a centralized data center. This enables computing resources to be distributed closer to information sources, potentially reducing network latency and congestion within the metaverse. Fog computing extends the edge computing architecture by introducing an additional computing layer that separates the cloud server from edge devices. This can enhance computational power and response speeds to support an expanding set of metaverse applications. And in future, quantum computing, which uses quantum mechanics principles to support complex data computation, may resolve the data processing power limitation of the existing computing infrastructure within the metaverse. 3. Sensing technologies. As metaverse moves from concept to reality, virtual reality, augmented reality, and mixed reality are a necessary intermediate stage. To a certain extent, virtual environments are the technical foundation of the metaverse. Extended reality, or XR, is the technology that integrates the digital and the physical world to various degrees. It actually encompasses other concepts and technologies such as augmented reality, AR, mixed reality, MR, and virtual reality, VR. AR technology superimposes virtual elements, such as virtual objects and characters, on a real-life environment, enhancing metaverse users' feeling of presence. MR technology builds on the features of AR technology to create interactive virtual elements. VR technology creates a virtual environment independent from the real world, which users can experience through visual and auditory senses. Each of these technologies thus offers a slightly different way to engage with the metaverse. All these above sensing technologies are considered to be essential for simulating perceptions of the virtual environment and delivering immersive user experiences in the metaverse. 4. Artificial intelligence technologies. AI technologies including computer vision, natural language processing, NLP, machine learning, and generative AI can synergize to empower interactions and content creation within the metaverse. Computer vision can analyze and incorporate visual information from users' real-world surroundings into the construction of the virtual space. NLP can interpret and process written text and the spoken languages used by metaverse users. Machine learning, the backbone of many AI applications in the metaverse, can improve AI-generated outputs by identifying patterns in datasets. Generative AI can create multimodal content. AI technologies offer a wide range of functionalities that can shape the metaverse experience through different channels. One notable example is generative AI, which can dynamically generate new metaverse content, such as virtual environments and objects, based on user commands. In addition, the development of explainable AI is expected to play an important role in addressing difficulties in explaining and validating AI-driven outcomes. This development may enhance the monitorability and transparency of AI applications and inspire the large-scale deployment of responsible AI models within metaverse-related activities. 5. Blockchain and other forms of distributed ledger technologies. Integrating blockchain into the metaverse signifies a transition from Web 2.0 to Web 3, creating a decentralized and democratized environment. The Web 3 metaverse, powered by blockchain's immutable and permissionless nature, eliminates the need for central authorization and ensures censorship resistance. This grants users control over their content, personal data, and self-sovereign identity. A blockchain, in essence, is a distributed ledger that keeps a record of information. Think of it as a database, shared across a network of interconnected devices in different locations. Distributed ledger technologies, or DLTs, operate on a peer-to-peer, P2P basis, where every node maintains a copy of the shared database. DLTs rely on consensus protocols to manage archives of data, such as user transaction records, ensuring the accuracy and integrity of the information. Different forms of DLTs exist, and each has specific functionalities that can facilitate various operations in the metaverse space. The DLTs can be classified into 4 common types of structure: private ledgers, public ledgers, permissioned ledgers, and permissionless ledgers. The most common type of DLT is based on public and permissionless distributed ledgers, employed by major blockchains to manage an immutable archive of data in a competitive and decentralized manner. Increasingly, attention has been directed towards DLTs operating with private and/or permission distributed ledgers. These DLTs leverage a centralized governance framework, albeit with varying degrees of censorship, and can enhance the security of transactions executed on distributed ledgers. Blockchain technology enables asset ownership and transfer in metaverse platforms through cryptocurrency wallets, non-fungible tokens, NFTs, and smart contracts. Wallets store keys for cryptocurrency transactions and often provide encryption and signing functionality. Other blockchain-based crypto assets, such as digital currencies and tokens, facilitate real-time cross-jurisdictional payments for metaverse users. NFTs, with their unique identification codes and metadata, allow users to track asset ownership and sales. Smart contracts automate operations based on predefined conditions, supporting asset monetization and metaverse governance. Through NFTs and smart contracts, the Web3 metaverse combines features of ownership and creator economies. The ownership economy allows users to retain full property rights, underpinned by a democratized governance system, using tokens for transparent collective decision-making. The creator economy in the Web3 metaverse empowers users to monetize their digital creations directly. This system reduces reliance on intermediaries, allowing creators to retain more value from their work. Smart contracts can automate royalty payments, ensuring creators receive compensation for secondary sales of their digital assets. In conclusion, when you combine all these focused technologies, the result is a powerful virtual universe of potentially unlimited virtual worlds. The metaverse is indeed a fascinating concept, and once introduced will change the way we live, conduct business and commerce, indulge in social activities, and perhaps even become a powerful means to unite all humanity. We hope you liked this video. Please subscribe and join our channel for more content on the metaverse concept. Thanks for watching.